Good morning to one and all. Now see this, in this today's live lecture we shall discuss the integration of unbounded function. Now what is meant by how to calculate the integration of unbounded function? See this actually in this lecture number 18. Now this is the unit number 3rd, that is improper integral, and in that improper integral we shall consider the range of integration is finite. Now see here, today we shall discuss the integration of an unbounded function with the finite limit of the integration. See this, in the last lecture we have seen that the Riemann integration is totally completely based on the partition of the given interval. We can find the integration of any function. Arvind Pawar, Rutuja Kaldate, Mukund, Shira Dhonkar, Sima Thakur, Sakshi Kamble, Digambar Imde, Aishwarya Andare, Harish Khan. See this, the concept of a Riemann integral is totally depend on the partition, and the partition is possible when only when the given domain is finite, that is f is bounded on a closed interval AB, that is it is bounded on the interval AB. Then we can take the that is a partition of that closed interval AB. By using that partition we can find the upper sum, lower sum or Riemann sum, and by using that upper sum, lower sum, Riemann sum we can find the integration. This is the basic idea which we have studied in the first chapter. But that integral, Riemann integral, is having the some limitations. What is that limitation? It must be finite, range of the integral must be finite, and the function remains bounded in the domain closed interval AB. ये दो कंडीशन सेटिस्फाई होते हैं तो हम उसका इंटीग्रेशन निकाल सकते हैं. अगर ये दोनों कंडीशन सेटिस्फाई नहीं होती, अगर एक आधी कंडीशन नहीं सेटिस्फाई होती, तो our problem how to find out integration. So we have to move towards the next type of integral. This is the improper integral, and that type is called as a improper integral. अगर function range is not finite or it is unbounded, तो हम यहाँ पे Riemann integration यूज नहीं कर सकते. अगर Riemann integration यूज नहीं कर सकते, unbounded function है, इनफाइनाइट नंबर ऑफ डिसकंटिन्यूटी पॉइंट्स है, तो हम यहाँ पे Riemann इंटीग्रल यूज नहीं कर सकते. तो हमें उस टाइप के इंटीग्रेशन कैलकुलेट करने के लिए we have to discuss another type, that is improper integral. What is mean by improper integral? Also we have seen in the detail what is mean by improper integral, what is the definition of improper integral, we have seen in the last lecture. See this, see this first example. Suppose if the first example, सांगा रे students, first example चा lower limit किती आहे, upper limit किती आहे सांगा. Now you tell me in the first example the lower limit and upper limit. See this, in the first example lower limit of that integral is 1, upper integral is infinity. So it is bounded at a point B. Upper limit is infinite, that is it is unbounded at a point B. So the domain of this integral is 1 to infinity, means it is unbounded. Then how to solve such integral? Such integrals are called as a improper integral. जिस इंटीग्रल के लोअर लिमिट और अपर लिमिट और बोथ, लोअर लिमिट और अपर लिमिट और बोथ इनफाइनाइट होते हैं, इन्फिनिटी होते हैं, तो अनबाउंडेड होते हैं, तो इस तरह के इंटीग्रेशन को हम improper integral कहते हैं. Second, it is also possible improper integrals are also in another way. Which is that? Which is way of that integrals here? In another way means what? One minute. See here. Suppose the lower limit of this integral is see this example number 4. In that example number 4, the lower limit of integral is 0, upper limit of integral is 5. That means domain is 0 to 5. Means it is a bounded. It is a finite domain. Can we say that this is a proper integral? No, because if here the domains are finite, that is bounded from A to B, but actually the function, if we observe the function 1 upon x plus 4 into x minus 2, if we observe this function 1 upon x plus 4 into x minus 2, if we put x is equals to 2, which is belonging to the domain 0 to 5, then function will discontinuous. The value of function tends to infinity. तो इस तरह के भी इंटीग्रल को हम इम्प्रॉपर इंटीग्रल बोलते हैं, सेकंड टाइप के इम्प्रॉपर इंटीग्रल बोलते हैं. यहाँ पे फंक्शन डोमेन बाउंडेड है, लेकिन फंक्शन यहाँ पे इम्प्रॉपर है, फंक्शन बाउंडेड नहीं है. सो वी हैव टू फाइंड आउट द इंटीग्रल ऑफ सच फंक्शंस. Such integrals are called as improper integrals, and we have to solve the integral of such a function. See this improper integral. Now, how to solve the improper of integral, or how to solve the improper integral of such functions? See this. These are the different examples here, first, second, third. These are the first type example, that is domain is unbounded, and second type 4 and 5, these two equations are the function discontinuous in the given domain. Okay, so we can say that. Now how to solve this type of integral, we shall discuss this. Okay, now see this. 1 minute. Now how to solve such integrals, now we shall discuss this. Now see this. First integral is infinite discontinuous at right end at a point B. Second integral is infinite discontinuous at left end at a point A. So these are the different conditions. According to these conditions, we can find the continuity of the given differential equation. See this. Now we shall discuss, we shall study the concept regarding this. 1 minute. Ganesh Patil, Mohammad Faizan, Sheikh, improper integral. Are you understand this concept of improper integral? Vaishnavi Bhutada. Okay, now see this. Next we shall discuss the concept of improper integral. The integration of unbounded function with a finite limit. Now how to calculate the integration of unbounded function with a finite limit, we shall discuss this. म्हणजे आता या टाइपचे जर इंटिग्रल असतील तर असे इंटिग्रल्स कसे सॉल्व करायचे, हाउ टू फाइंड आउट द सोल्यूशन ऑफ सच इंटिग्रल्स, वी शall डिस्कस. नाउ फर्स्ट डेफिनेशन. नाउ वी shall write the definitions here. Definition of the condition, 1 minute. let a function f be defined on an interval closed interval a comma b everywhere except possible at a finite number of points. See this. Now, number one, we shall discuss the convergence at the left end. First, convergence at the left end. Now, how to calculate the integral of improper integral, that is, which is having an infinite discontinuity at the left hand. See this, integral of this type 0 minus infinity to 4 1 upon x plus 2 dx. See this the domain of this integral is a minus infinity to 4, means it is a discontinuous, or it is a infinite at the left end. This is a left end, this is a right end. इस तरह के इंटीग्रेशन को हम हाउ टू कॅल्क्युलेट वी शॅल डिस्कस दिस. ओके, तर जे लेफ्ट एंडला डिस्कंटिन्युअस असतात त्याचे इंटिग्रल कसे घ्यायचे पहा. लेट सी दिस स्मॉल a be the only point of see this at the let a be the only point of infinite discontinuity of f, so that according to the supposition the integral from a plus lambda to b f dx exists for every lambda such that 0 is less than lambda is less than b minus a. Okay, then the improper integral we can write this supposition. Improper integral from a to b f dx is defined by as the limit of integral a plus lambda to b f dx when lambda tends to 0, positive. Okay, see this, suppose the given integral is infinite discontinuous at the left end, that is at a point a, means minus infinity to suppose 0, minus infinity to 4, then according to our assumptions we have to exist the value of that limit at the left end for this integral, such as integral from a plus lambda to b f dx exists for every lambda, such that 0 is less than lambda is less than b minus a. The improper integral a to b f dx is defined as the limit of a plus lambda to b f of x dx when lambda tends to 0. Or we can write this as, therefore we can write this as, therefore integral from a to b f dx, which is equals to limit lambda tends to 0 positive a plus lambda to b f dx. See this, if this condition, if this limit exists, see, if this limit exists, the improper integral integral from a to b f dx is said to be exist or converge at a, otherwise it is called divergent. See this, if this limit exists, हे सर्वात महत्वाचं आहे पहा, if this limit exists, हे जे लिमिट एक्झिस्ट व्हायला पाहिजे ते होतं का पहा. सो वी कॅन से दॅट इट इज कॉन्वर्जंट और वी कॅन राइट दिस एज अ डायवर्जंट. सी दिस. ओके, नाउ वी कैन राइट दिस सेकंड. अभी हम दूसरा एग्जांपल एक देखते हैं. कॉन्वर्जेंस एट द राइट एंड. सेकंड, कॉन्वर्जेंस एट द राइट एंड. We shall see first example. Consider the integral. अभी देखो मैं एक इंटीग्रल बताता हूं. सपोज इंटीग्रल फ्रॉम 1 to infinity dx डिवाइड बाय एक्स स्क्वायर प्लस 2x प्लस 1. अभी देखो क्या होता है. चलो रे स्टूडेंट्स, इसका लेफ्ट एंड यानी कि लोअर लिमिट, राइट एंड मीन्स अपर लिमिट, इसके राइट एंड एंड लेफ्ट एंड बताओ रे मुझे. सो यहां पे लिमिट्स ऑफ दिस इंटीग्रल इज फ्रॉम 1 to infinity. That means it is a left end, this is a right end. If we suppose this considered as a to b, closed interval a to b, if we suppose closed interval a to b, continuous कहाँ पे है देखो, discontinuous कहाँ पे है, it has a value infinite at the right end. That means this integral is improper because it has infinite value on the right hand, that is given domain is unbounded. Now it is improper at the right hand, it is divergent at the right hand, it has a value infinity. Right hand means at a point b, 1 is left hand, infinity is right hand. अभी देखो यहाँ पे डाइवर्जेंट है, it goes to infinity, वो right hand ला divergent है, b ला divergent है. Now how to find out this integral, how to convert this improper integral into the convergent, we shall discuss this. That is convergent at the right hand. How to calculate the convergence at right hand here. मी शॉर्ट मध्ये देतो, याची डेफिनेशन एवढी मोठी लिहित बसायची गरज नाही आहे, शॉर्ट मध्ये लिहितो. लेट let small b be the small b be the point of infinite discontinuity, be the point of infinite discontinuity of f, the improper integral because b is the infinite discontinuous point, b has a value infinite, so it is discontinuous at the point b, at the right end. Now how to find out this integral? Improper integral is then defined by the relation that is integral from a to b f dx, which is equals to limit mu tends to 0 positive integral from a to b minus mu. हे महत्वाचं आहे, a to b minus mu f dx, where 0 is less than mu is less than b minus a. See this, if the limit exists, if the limit exists, comma, the improper integral is said to be convergent, said to be convergent at b, otherwise it is called divergent. If this limit exists on the right hand, see this, इथं कसं आहे, if this limit exists on the left hand, integral from a to b f dx, which is equals to limit lambda tends to 0 positive a plus lambda to b f dx, if this limit exists, then we can say that it is a convergent at the left hand at the a, otherwise it is divergent. Okay, in this way same process. Now third, we shall discuss the third example, third condition. Okay, what is the third conditions here? 1 minute. Third, convergent at the divergent at the both end. See this, divergent at the both end, converges. So we shall find the convergence at the both ends. See this, convergence at the both end. We shall discuss the convergent as the both end. Now how to define this? Suppose the integral of the type, which is this type, suppose integral from minus infinity to plus infinity, 4x divided by x square plus 2 dx. If you observe this, then we can say that it is infinite discontinuous at the left hand. infinite discontinuous at the right end means suppose A and B, suppose this is infinite discontinuity, this is infinite discontinuity, means the given integral is improper at the both the end. Then how to calculate, how to convert this improper integral into the proper integral, how to find out the integral value of this function, we shall discuss this. Okay. Now we shall write this same process. One minute, see this. Let A and B are the n points that are infinite discontinuity, discontinuity of f if the limit exists, if both the integral, we can say that if limit or integral from A to B f dx which is equals to, आता दोन लिमिट घ्यायचे पहा, दोन्ही साइडला इन्फायनाइट डिस्कंटिन्यू आहे. See this f dx, we can take the limit lambda tends to 0 positive, mu tends to 0 positive, integral from a plus lambda to b minus mu f dx. If this limit exists, the improper integral exists. If this limit exists, then we can say that if this limit exists, then the improper integral is said to be convergence at the both end, that is both end bracket मध्ये at A comma B, otherwise it is said to be divergent. It is said to be divergent. See this. आणि लास्ट जो राहिला आता तो पार्ट म्हणजे कोणता आहे पहा, fourth part. See this, we shall discuss this fourth part. That fourth part is, suppose convergence at the interior point. At the interior point. Convergence at the interior point. Suppose, see this example is like this. If we consider the example number 4, left end is 0, right end is 5, means they are finite. They are not finite discontinuous. Infinite discontinuous, they are actually finite. 0 is a finite, 5 is also finite, means both end are finite, which are not infinite discontinuous. So we can say that it is a finite domain. But if we observe the function, dx divided by x plus 4 x minus 2, then this function is discontinuous at x is equals to 2. That means C is the point of discontinuity of f. Here the point C म्हणजेच 2. The point C is, it is a continuous at A, it is a continuous at B, but the function is discontinuous at a point C is equals to 2. मग आता C is equals to 2 ला जर तुम्हाला डिस्कंटिन्युअस असेल तर ह्याचं इंटिग्रल कसं करायचं? तो इंटिरियर पॉईंट आहे, 0 to 5 च्या मध्ये आहे. दिस इज द इंटिरियर पॉईंट. मग ह्याचं कॉन्व्हर्जन्स कसं कॅल्क्युलेट करायचं हे आपण इथं पाहू. सो सी दिस, वी कॅन राईट दिस साइज. इफ an interior point see this, suppose C comma there A is less than B is less than C, is the only point of infinite discontinuity. Infinite discontinuity of f. So it is improper integral. Then it will be converged. Then we have to write, then we have to convert, we have the improper integrals at a point C, so we can write limit integral from A to B f dx, which is equals to integral from A to C f dx plus integral from C to B f dx. Here is note that C is infinite discontinuous point because f of x is discontinuous at C, f of x is discontinuous at C. If both these improper integrals on the, that is the integrals on the right sides are exist, then we can say that the given integral is convergent. आता ह्याचं कसं घेतलं जातं? पहिल्याचं इंटिग्रल limit, see this, that can be written as, we can write integral from A to B f dx, which is equals to limit mu tends to 0 पॉजिटिव, हर एक जगह पे 0 पॉजिटिव रखना है, ठीक है? हाँ, ओके. Mu tends to 0 positive, integral from A to C minus mu f dx plus limit lambda tends to 0 positive, because it is second integral is infinite discontinuous at the left end, first integral is infinite discontinuous at the right end, so we have to take the limit left hand and right hand. अगर left hand है तो lambda tends to 0 positive लेना है, अगर right hand है तो mu tends to 0 positive लेना है. mu है तो c minus mu लेना है, यानी c b lambda है तो a plus lambda लेना है. तो we can write this as a c plus lambda to b f dx. If this both, if the both limits exist on RHS, then we can say improper integral is convergent at point C, otherwise it is divergent. Otherwise it is divergent. See this. Okay, we shall see convergence at the interior point. If an interior point C such that A is less than B is less than C is the only point of infinite discontinuity of F. C is the infinite discontinuous, it is the interior point. So we have the improper integral from A to B of dx, which can be written as integral from A to C, C to B. By the property of definite integral, we can separate this integral. This implies that integral from A to B of dx is equals to limit mu tends to 0 positive A to C minus mu f dx, because C is a point of discontinuity of first integral. Limit lambda tends to 0 positive C plus lambda to B of dx. If both the limits are exist, then we can say that the given integral is convergent at a point C, otherwise it is divergent. मग आता जर असे जास्त पॉइंट असतील C1, C2, C3 असतील तर we can separate this integral. We can separate this integral more than two or three points. Means as like integral from A to C1, C1 to C2, C2 to C3, dot 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 in this way, Cn minus 1 to Cn and Cn to B. In this way we can separate this. जर जास्त पॉइंटला असतील तर हा एक आपण एकच पॉइंट घेतला सी, एकापेक्षा जर जास्त असतील तर वी हॅव टू सेपरेट दिस. म्हणजे कसं पहा, उदाहरणार्थ तुम्हाला सांगतो. सी दिस. नाउ वी कन्सिडर द एक्झाम्पल. सपोज इंटिग्रल फ्रॉम 1 to 6 dx डिवाइड बाय, चला रे स्टुडंट सांगा बरं आता मला हे डिस्कंटिन्युअस पॉइंट सांगायचे या एक्झाम्पलचे. डिस्कंटिन्युअस पॉइंट सांगा. दॅट इज x minus 4 x minus 3. Now if we observe, left end is 1, right end is 6, means both are finite. That means integral is finite at the both end, at the point A and at the point A, at the point B. Suppose this is A and B. Means here A and B are the bounded. It is not unbounded integral. That is 1 to 6. Bounded. But if we observe this function f, which is given by x minus 4, x minus 3. This function goes to infinity when x is equals to 4, x is equals to 3. Very good. सायली काळे, ऋतुजा काळदाते, व्हेरी गुड. याच विद्यार्थ्याचं लक्ष आहे पाहिजे. विद्यार्थी आन्सर देतात ना, त्याच विद्यार्थ्याचं फक्त कॉन्सन्ट्रेशन आहे असं कन्सिडर होतं. लक्षात येईल का रे? तेच विद्यार्थ्याचं कॉन्स्टंट कॉन्सन्ट्रेशन आहे. ओके. फॉर अँड दीज 2 points आर बिलॉंगिंग टू क्लोज्ड इंटरवल 1,6. हे दोन्ही पॉइंट क्लोज्ड इंटरवल 1,6 मध्ये आहेत. मग हाऊ टू कन्वर्ट दिस? सो वी हॅव टू राईट दिस इंटिग्रल इन सच अ वे दॅट इंटिग्रल फ्रॉम 1 to 6 dx डिवाइड बाय x minus 4 to x minus 3. म्हणजे कसं आहे पहा, 3 ला आणि 4 ला डिस्कंटिन्युअस आहे. 1 is less than 3 is less than 4 is less than 6. So these 2 points are discontinuous point. Now how to calculate this value of this integral? We have to distribute this integral by the properties of definite integral from integral 1 to 3 dx divided by x minus 4 x मायनस 3. दुसरा हे 1 to 3 साठी झाला. आता 3 to 4 इंटिग्रल फ्रॉम 3 to 4 dx divided by x minus 4 x minus 3 plus integral from 4 to 6 dx divided by x minus 4 x minus 3. Now calculate the limit. Here the calculate the limit at 3 by taking mu. It is a first integral is discontinuous at 3. Now second integral is discontinuous at both the ends. So calculate the limit. 3 plus lambda to 4 minus suppose mu. Taking a limit mu tends to 0. Lambda tends to 0 positive. So this integral is now third integral is improper at the left end. So we have to take 4 minus 4 plus lambda to 6 आणि यांचे लिमिट कॅल्क्युलेट करा. लिमिट lambda tends to 0 positive, mu tends to 0 positive. Calculate the separate limit for each example. Then we shall, if this limit exists, हे जर लिमिट निघाले, then we can say that the function is, given integral is convergent at the point 3 and 4, otherwise it is a divergent. हे लक्षात आलं का रे? अशा पद्धतीनं जर इंटेरियर पॉइंट आला तर या पद्धतीनं घ्यायचं. ठीक आहे. समजा दुसरं एक्झाम्पल घेऊ आपण. We can write second example. Suppose 1 minute. We can consider the second example. Suppose integral from 0 to 5 2x divided by x minus 1 x plus x minus 6 x minus 6 dx. 2x divided by. Now here 0 is a finite, 5 is a finite, so closed interval 0 to 5 is bounded. But function f of x is equals to 2x divided by x minus 1 x minus 6. This goes to infinity. सांगा रे कुठल्या कुठल्या पॉइंटला इन्फिनिटी आहेत स्टुडंट्स. नाव यू टेल मी which points at which the given function is at infinity. चला सांगा रे कोणत्या पॉइंटला इन्फिनिटी आहे सांगताय का? At which points the functions are infinity? We can say that at x is equals to 1 and x is equals to 6. But note that 6 is not in the given domain 0 to 5. So here x belongs to x is equals to 1 belongs to the domain 0 to 5. 6 does not belongs to 0 to 5. मग 6 येत नाही म्हणून 6 ला घ्यायची गरज नाही आहे. फक्त 1 साठी चेक करा. मग याला कसं लिहावं लागेल? Therefore we have to use integral from 0 to 5 2x divided by x minus 1 x minus 6 dx. 6 तर बाहेर आहे. 6 ला discontinuous येतं फंक्शन, but which is not in the domain. So we have to convert only 0 to 1 2x divided by x minus 1 x plus 6 dx plus 1 to 5 2x divided by x minus 1 x minus 6. आता याचं काय करावं लागेल? We have to calculate at the right end, that is mu. We have to calculate at the left end, that is lambda. So we can take this way, we can write this. Okay, अशा पद्धतीनं आपण इथं इंटिग्रल सॉल्व करू शकतो. इथं +1 plus lambda आणि हे लिमिट म्यू आणि लॅम्बडा टेन्स टू 0. इफ दिस लिमिट एक्झिस्ट then we can say that given function is convergent, given integral is convergent at the point 1. अशा पद्धतीने हे इथं होतं. नाउ वी शॅल स्टॉप हिअर. याच्यात काय अडचण आली तर विचारा. आता ॲक्च्युअली याच्यावरचे जे प्रॉब्लेम्स आहेत ते आपण प्रॉब्लेम्स उद्याला घेऊ. ठीक आहे. ओके. नाउ वी शॅल स्टॉप हिअर.